Okay, let's go through some of these problems here. So this one says the exponential function models the annual rate of increase. Find the monthly and quarterly rates. So to find the monthly rate, you just have to take the annual rate and raise it to the 1/12th power. And to find the quarterly rate, you just have to take the annual rate and raise it to the 1/4th power. And again, that's because for this guy here, monthly is 12 times a year. So 1.03 to the 1/12th. So we're sort of just undoing what we would do otherwise. That would be 1.002466. So that's 0.2466% would be our monthly rate, and we would expect our quarterly rate to be a little bit higher. And that is in fact the case, because this comes out to be 1.007417, which means that the quarterly rate is 0.7417%. Okay. Same thing for number 6. Probably will not actually figure out what this works out to be. You could do it on your calculator if you want to figure out the monthly rate. You would raise that to the 1/12th power, and to figure out the quarterly rate, you would raise this. You would raise this to the 1/4th power. Okay. So I'll let you come up with those numbers on your own if you want. Alright, next one, find the total amount of money in the account at the end of the given time period. So for number 7, we are starting with 2,000 doleros. We are doing this at 3%, so that is 0.03. We are compounding it monthly, so that means we have to take the interest rate and divide it by 12. But that means we're going to take the time period and multiply it by 12. And so, when you do that, let's see, 2,000 times 1 plus 0.03 divided by 12, and I'm going to raise that to the 60th power. So I would have $2,323.23 in my account in that case. Okay, if I do this compounded continuously, so here's this magic word, that means we're using a completely different formula. I'm going to take the amount that I'm starting with times e to the interest rate as a decimal, so 0.015 times the amount of time. Gosh dang it, I keep forgetting to help you all out by putting that in parentheses. Okay, so again, on Desmos, 1500, go to the keyboard, e to the parentheses, 0.015 times 6 means I end up with this much monies. Okay, so those are pretty straightforward, pretty easy problems. Okay, same thing here. He's starting out with $6,450. It's continuously compounded interest, so that's, we want to use E for that. And we're going to raise that to the 2.8% as a decimal is 0.028 times 8 years that it's invested equals, so we'll change this to 8. And I'm going to change that to 0.028. And this person has more monies. 6,450. So they end up with $8,069.41. Okay, a little error analysis here. Suppose $6,500 is invested in an account that earns an interest rate of 2% compounded quarterly for 10 years. Describe and correct the error the student made. Okay, so if we're compounding quarterly, then this should not be a 12, this should be a 4, and that should also not be a 12. That should be also a 4. So sadly, they won't have quite as much money as they thought they were going to have because they're not putting interest in the account as often as they thought they were. But it's really not going to change by much. I'll put that in there as a 4. And then I'm going to raise that to the 40th power. They would end up with $7,935.16. Okay. Alright, so now we're just going to crank through some of these boring ones. I am not going to go through and type out or figure out on the calculator what the actual answer is. I'll just show you what you could type into your calculator to figure it out. So for number 16, if I'm starting out with $800, I always need that 1 to stand for the original amount that I've invested. That is at 6% interest, so that's 0.06. Compounded quarterly means 4 times a year. And we're doing that for 9 years, so that's going to be raised to the 9 times 4 power. And whatever you get from that is your answer. Compounded monthly, starting with $3,750. I'm going to go 1 plus 3.5% as a decimal is 0.035. Monthly is 12 times a year. This is 20 years monthly, so times 12, whatever that equals is what you end up with. Okay, number 18, we're starting with $2,400. We are getting a 5.25% interest rate, so 0.0525. This is compounded semi-annually, so that means twice a year for 12 years, so 2 times 12, or you can just put a 24 there, type that in. That'll give you the answer that you're looking for. Let's change colors here because I'm bored. Okay, so now it's $1,500, and I have an interest rate of 4.5%, so 0.045 compounded daily. So there are 365 days in a year. Anyway, so 3 years times the 365 days a year that you do it. Figure that out. Okay, and then these last two are compounded continuously. That's the magic word that clues us in that we're changing formulas. So we're using E instead. So this would be an interest rate, 2.8% is going to be 0.028 times 5 years. So let me get that there. And then 21 is $16,000. That's a nice chunk of change. Again, compounded continuously, so we're using E. 4% as a decimal is 0.04, and that's for 25 years. So type that in, and that's how you get your answer there. All right, the next one. Adam invests $8,000 in an account that earns 1.25% interest compounded quarterly for 20 years. Oh, this exact same date, Jacinta invests the same amount of money in an account with the same interest rate for the same amount of time, but her interest is being compounded continuously, where his is only being compounded quarterly. So who's going to end up with more money? Well, in this case, it will be Jacinta. She is getting interest added to her account more often, so she will end up with more moolah. Okay, that's kind of the theme, what this is all about there. More often means more interest, means more money. Okay, next one. A blogger found that the number of visits to her website increases 5.6% annually. The website had 80,000 visits this year. Let's start by writing an exponential function that models that. So we are doing 80,000 times 1 plus. Okay, annually, so I don't need to divide this by anything. I'm just going to change this into a decimal, and then raise that to some variable t. Okay. So she's curious to know what percent, by what percent visits are increasing daily. So to do that, I'm going to raise this to the 1/365th. And do we have a name here? No, just a blogger. It's going to be a pretty small number, Miss Blogger, because you're only going up by 5.6% over the course of the whole year. So daily, this works out to be 1.000149, which means if I move this over 2 places, that would be 0.0149% each day. So we're going up by 0.0 blah 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 each day. Yeah, not very much, but whatever, keep at it. Get your message out there. All right, Jay invested $3,500 at a rate of 2.25% compounded continuously. How much will be in there in 2025, and how much of that will be interest? Okay, so the magic word in this problem is, again, continuously. So that means we're using the E formula, the PERT formula. So 2.25% as a decimal is 0.025 times, if I start in 2010 and I end in 2015, that's a total of 15 years. So, in the end, Jay, whose parents spelled his name wrong, will have, let's see, 0.025. Yeah, I forgot to put that in parentheses. Shame. Times 15. So Jay would end up with $5,092.47. So if we want to know how much of that is interest, then we could just subtract off the original $3,500 that he invested, and that would give us $1,592.47 interest. So that's nice. That's handy. Free money. Can't complain about that. I mean, you could, but you'd be dumb. Ooh, this looks tricky. All right, the table shows the account information of 5 different investors: Anna, Nick, Lori, Tara, and Steve. Which of the following are true, assuming no withdrawals are made? Okay, so this says after 12 years, Anna will have about that much in her account. So let's do, what is she starting with? 4,000 times 1 plus 0.015 divided by, she is going quarterly, so divided by 4. And then that would be to the 4 times 12th power. And let's see what she has won. 4,000 times 1 plus 0.015 divided by 4 to the 4 times 12 is 48. 48th power. I get 4,787.25. So close, but no. Okay, let's try the next one. After 8 years, Nick will have about that much in his account. So same dealio. We're going to go 2,500 times 1 plus 0.03 compounded monthly for Nick. So we're going to divide by 12. And then we're going to raise this to the 8 times 12th power because 8 years, once a month, so 8 times 12, so 2,500 times 1 plus 0.03 divided by 12, oops. And we're raising this to the essentially 96th power. So he gets 317717. Yep, so that is a winner. So this one is true. Boy, so we got to do each one of these, huh? Yuck. Who assigned this problem? So then for Lori, after 15 years, so she's going 7,200 times 1 plus her interest rate is 5%. Nice job, Lori. She's got the best one. Divided by annually, so we don't have to divide by anything there. And she's going for 15 years. Okay, so let's see what that comes out to be. 7,200 times 1 0.05 to the 15th. She ends up with 14,968. So nope, that's wrong. How about Tara? She's starting with 2,100. 1 plus, she's at 4.5%, so 0.045. She's going continuously, gosh dang it. So that means I need to use E, so I'm going to go E to the 0.045 times 6. So let's see what that works out to be. 2,100 times E to the 0.045 times 6. So she ends up with 2,750.93. Yep, so that is winner, winner, chicken dinner. And then let's figure out how much money Steve would have in 20 years. He's going semi-annually, so 3,800 times 1 plus 0.035 divided by 2 to the 2 times 20 power. Okay. Point 0.035 divided by 2 to the 40th. 7, 6, nope, didn't work out. That one's a loser also. So B and C. All right, last one. Rick invested money in a continuous compound account with an interest rate of 3%. How long will it take Rick's account to double? So it doesn't say how much money, so let's just give him some money. Let's say $1,000. E to the parentheses 0.03 times, and then let's put in some of these different times and see which one works. And we're going to learn, like I think I mentioned last week, later in this chapter, how to figure this out without just doing a guess and check. But let's, for now, do it that way. So 1,000 times e to the parentheses. I'm thinking 2 years is not going to be enough, so I'm not even going to bother with that one. I'm going to start with, let's go 23. So 23 years, he has $1,993, which is about double. If I did 46 years, that would be 3,974. That's way too much. So if I do this to the 23rd power, is what I'm saying, then I get 1993, which is about twice as much, so that would be about 23 years to double. Okay, hopefully that helped. Don't know if anybody's watching these at all, but you do what you can. Okay, see you tomorrow.